This is the multiple series forecasting assignment. First, we import the packages and then we'll load. This is my API key for the Nextla client. Now we load the data set. This is the head of the data set. Now we plot using the dot plot function. After that is done, to forecast all series at once, we simply pass the data frame to the df argument. TimeGPT will automatically forecast all the series. You can also complete prediction intervals for historical forecasting by adding add history equals to true. Here we have added that. With confidence levels of 80 to 90%, we can see that historical predictions are made by TimeGPT. Now let's see the fine-tune assignment. First, we install the required packages and we load the data. Here I have used the electricity.csv file. Then we set fine-tune steps to 10, and this means the model will go 10 iteration of training on the data set. It is also possible to control the depth of fine-tuning with fine-tune depth parameter. Uh, Fine-tune depth takes values among 1, 2, 3, 4, and 5. By default, it is set to 1, which means that a small set of modus parameters are being adjusted, whereas a value 5 fine-tunes the maximum amount of parameters. Increasing the fine-tune depth also increases the time to generate these predictions. So you can see the increasing depth of fine-tuning can improve the performance of the model, but it can make it worse too due to overfitting. Now let's see for the anomaly detection. First, as usual, we install the required packages, then we use the API key of the Nextla, then we can see the data's head, and we use the plot function to plot the data. We now use the anomaly detection. By default, TimeGPT uses a 99% confidence level. If a point falls out of the interval, it is considered to be an anomaly. Uh, 0 is assigned to normal values as they fall inside the confidence interval. A label of 1 means is then assigned to the abnormal points. We can also plot the anomalies using an Excel client. Uh, Anomaly detection with exogenous features. Previously, we performed anomaly detection without using exogenous features. Now it is possible to create features specifically for this scenario to inform the model in its tasks of anomaly detection. We use the date underscore features argument for it. We can set it to true and it will generate possible features from the given dates and frequency of the data. Then we can also plot the weights of each feature to understand its impact on anomaly detection. We can modify the or tweak the confidence intervals by using the level function, which is now set to 70. And here is the uh, plotting of the same. Next, we use the energy forecasting. Uh, we first install the required packages, use the API key from Nextla client, and load the data. Once the data is loaded, we plot the data with the max in sample length of 365. The first step is to split our data. Here we define an input data frame to feed the model. We also reserve the last 96 time steps for the test set so that we can evaluate performance TimeGPT against actual values. We simply call the forecast method this method. We use fine tuning and specify the mean absolute error as the fine tuning loss. We then use the time GPT one long horizon, since we are forecasting the next 2 days and the seasonal period is 1 day. Then we can now plot the predictions against the actual values of the data set. Now we have our predictions. We can evaluate the model's performance. Uh, the data set is very large, so we use the last 362 days of the training set to fit our model. We now fit the model on the training set and make predictions. Here is the MAE value, and the now we use the Bitcoin forecasting assignment. First, we install the necessary packages and load the data. For our convenience, we will rename the date and close columns to DS and Y respectively. Once we set our API key here, we can use an extra client. This is the uh, data frame plotting. Now we are ready to generate predictions with TimeGPT. To do this, we will use forecast method from Nextla client class. It requires df, h, and level arguments, and then we can use that to plot a new graph. Here in forecast, we have given the data frame h, level, and add history to true. And now if we plot it, we can check comparatively. Now we can also use the detect anomalies function to check with the actual data set. Now let's see the RDL and relbench training dataset. A few changes had to be made in the torch and torch geometric libraries. The ones given in the IPYNB file in the assignment were not working. And here we also need to use T4 GPU. In the runtime, I had changed the runtime to T4 GPU, or else this wouldn't work. After installing the required libraries, we check out our training data. Now we introduce PyTorch frame library, which is useful for encoding individual tables into initial node features. We to build a graph out of the database, we use pre-prepared conversation function. PyTorch also stores the modality of each column and any specialized feature encoders to be used later. So we need to use the S type for each column. This the get S type proposal. Once that's done, if trying a new data set, we should definitely check out the dictionary of S type to check that look right and manually change any mistakes by auto detection function. Now we also define our text encoding model, which we use GLOVE embeddings for speed and convenience. Now this is data. We can now check the data. Our main graph object data is heterogeneous and temporal graph with node types given by the table it originates from. We can also check the tensor frame on the table, which looks like this. This may be a little confusing at first, as in GraphML, it is more standard to associate to graph object data to tensor, but actually this data object behaves similarly. The races again data is an race inside data stores two pieces of information, TF and time, tensor frame object and the timestamp of each node. And then we can also check edge indices between two different node types such as races and circuits. Now we are ready to instantiate our data loaders. For this, we need to import PyTorch geometric or GNN library. Whilst we are at it, let's add a seed. Now we need our model. We also need standard train and test loops. Now we are ready to train our model. The training is done. Um, so the two tabular assignments for this first one, after researching about this, tabula is not able to read the CSV file. This function as is not a very useful for using on CSV files. ChatGPT, Claude AI, or Perplexity is giving us different. Is asking us to use different libraries rather than this. So that was the reason I was not able to complete this assignment. And for this interface, I did check out this RFTM assignment as well. There are a few issues with this IPMD file that I'm facing. I'm also using uh, Perplexity to solve these. There is no module named rftm.configs. I did try to download different versions of RFTM, and I was not able to do it. The solutions provided by this was also not very useful. So I'm still trying on it. If I do get a way of working on these two portions of the assignment, I'll update the GitHub link and also will put a request to the sir saying that I was able to overcome the challenges I had faced. Other than these two, I have attached the IPYNB file called Google Colab links in the GitHub directory. Thank you.